problem. Now, what I want to talk about now is how we make that jump, how we actually bring about lateral thinking, how we make it happen. Now, in order to talk about that, I want to go back to the exercise which I had given you a little bit before the program, and if you remember, I had drawn a wheelbarrow, a rather strange-looking wheelbarrow, something like this, something like that, and I'd asked you to make 5 comments on that as a design for a wheelbarrow. And we've got your comments on cards. I haven't read the cards. We've got your comments on cards. And I'm going to ask Dinah to give me those cards. Could I have those cards? What I'm going to do is just read out some of the comments you made on that as a design for a wheelbarrow. The wheel is too small, it's unbalanced. Good-sized bucket. Awkward handles, how wide is it? Too much tilt to push forward and empty. Would not balance on ground, would not balance when wheeled. Over large capacity. 2 handles, could be towed rather than handle conveniently. The wheel support is too long, the wheel support is flimsy, the wheel support is too small, the drawing is not clear, there's hardly any information about how to make it or from what. Long handle, everything would tip out when let down, etc. Now, one time I gave this to a group of business people, and I counted the critical points, the things they found wrong with it, like some of those I just mentioned, and the interested points. And the ratio is something like this. For a group of executives, there was 20 critical points for every interested point. For a group, all of whom had an IQ, a very clever group of 140, there were 22 critical points for every interested point. For a group of teachers, there was 27 critical points for every interested point. For a group of youngsters between 12 and 13, there were 2 critical for every interested. Now, the reason that was quite low, the 2 reasons, one is they didn't know too much about wheelbarrows, levers, center of gravity. The other is they thought it was the best wheelbarrow I could draw, and they would try to be nice to me. So they said all sorts of things, like it's a good wheelbarrow for filling holes in the ground, because you can come to the end and just tip out your load. They said if you've got mud on the wheel, you could easily kick it off because your foot's near the wheel. They said you couldn't strain your back, because if you tried to lift more than your own weight, you'd take off. Then there was someone else who said, she said, since all the weight is on the strut, she was going to put a spring in there, and she was going to have the wheel-bearing strut moving in and out against the spring. And then she said she wanted to color that, so the top piece was red, and the bottom piece was green. And she said you could now tell exactly how hard everyone was working, depending on which color you saw as he went past. Now, the point of that is that instead of using judgment, something else was being used. By and large, when we think, we use judgment, as most of you did with the wheelbarrow example. We use judgment in order to find the pattern we should be using. We use judgment to stop us from wandering off the pattern and bring us back on track. But if we want to use lateral thinking, if we want to increase our chance of escaping from this track and getting to that track, because once we're there we can see it makes sense, we've got to use something different from judgment. And what we've got to use is something we'll call movement. We want to be able to use the movement value of an idea. So when we come to an idea, instead of judgment, it's wrong, it won't do, let's back away, what we want to do is say, let's see where that idea gets us, the movement value of an idea. And just as in the judgment system we have the word no, so in the movement system, lateral thinking, there's a word I invented called PO, which means possible, hypothesis, suppose, and so on. I'll give you an example of that. One time I was talking to a group and we were looking at airplanes, and I said PO, which is our word for provocation, PO, planes land upside down. Now what sort of things, what sort of useful idea could come from that? Any suggestions? Planes land upside down. Little fellow in front, any suggestions? Well, what someone said very quickly was, if planes landed upside down, the pilot would get a much better view. And from that came the idea that maybe, when we have airliners, maybe instead of the pilot sitting on top, maybe if we had the pilot sitting underneath, he could have a better view, it might have advantages. And I'm not saying it does, but it leads us to that idea. So let's do a quick exercise on that. Let's suppose we're looking at ordinary umbrellas. Now, supposing, as a provocation, someone comes along and says he wants to design an umbrella shaped like that. Now, what I want you to do in your little discussion groups, just look at that and see if it gives you any useful ideas about changing the design of an umbrella. So discuss it in your groups. All right, let's see what ideas we've got. Let's see whether that provocation provokes any interesting ideas. Let's have some suggestions. Anyone here?
We thought of the idea of having the water coming out the back, out of a chute, giving you power to go forward. So if you're on skis or something.
Okay, some way to push forward. All right, some others? Group over here, yes, all right, you?
Well, I thought of a kind of, you put it on this skateboard and it goes down this umbrella at the bottom.
Yes.
And then joins another pipe, goes down onto your skateboard.
I see, and
it goes through a process to make you go along.
make you go faster or something, all right? Anyone from anywhere?
We thought it would be very useful for politicians to have that sort of umbrella. Then if people throw rotten fruit at them, they could catch it and throw it back.
Okay, one of the important things here, one of the important differences, if we look at it, is that when the water lands here, the one place it doesn't go is off the edge. Never mind about it being collected. The one place it doesn't go off is off the edge. When all the water normally lands on an umbrella, it's all got to come off the edge, and if you're standing there, you get it on your trousers if there's a wind or something of the sort. So from this comes the idea, can we apply that principle to an ordinary umbrella? And the answer is we can. You can imagine an ordinary umbrella which, when it's opened up, there's a little flap here, a little gutter. Looked at from above, it's like this, which gets stretched and which comes up. So now all the rain which falls here, it goes out of the gutter, goes off the side, or goes off the back instead of coming down in front of you. So a very small change which comes from this, using this for its movement value. Let's look at another process. The other process is what we might call the escape process. And here, what we do is we try and identify something we take for granted, try and escape from it. So one time I was in a discussion group looking at London taxis. And the very few taxis in London, I think there's something like only 9,000, maybe a bit more than that, compared to 15,000 in Moscow and 30,000 in New York. The reason there's so few is you have to pass an exam called the knowledge. It takes you 18 months to pass the exam. No one pays you for learning, so why should you bother to be a taxi driver? So we said, what do we take for granted about a taxi driver? One of the things we take for granted outside of Tokyo is that he knows his whereabouts. So we say, let's escape from that. Let's have a taxi driver who does not know his whereabouts. What would he do? What would a taxi driver who does not know his whereabouts do?
Get lost.
He'd get lost. What else?
He'd ask the passenger.
He'd ask the passenger. As soon as you say that, you come to an interesting idea, which is this. You'd have normal taxis, as they are at the moment, and these are used by people from out of town, tourists, visitors, and so on. Then you'd have another type of taxi, and this other type of taxi is distinguished by the fact that there's a big question mark on the roof. That's because the driver doesn't know where he's going. Now, by definition, this is only usable by residents who do know where they're going. Say, go straight there, first to the lights, over the bridge, stop on the left. So what happens now is you have more taxis for these people because the residents aren't competing. The residents have taxis for themselves. This guy can be paid as soon as he can drive because he doesn't have to, he can be paid while he's learning, and eventually he moves up here and so on. So by escaping from an idea we take for granted, we create benefits all round. So that's another of the process of lateral thinking.